This video explain the example for the dead load, which determining the average uniform weight of the roof in kilopascals. So please note, we need to find it in kilopascals. If it is flat condition, so it's given here flat as shown in the figure and at a 10-degree pitch. So if I lift this one up 10-degree pitch, we need to find this one. So let me explain this one. The first layer of the roof is 0.5 millimeter CGI roof seating. Then the second layer is hardwood purlin, center to center distance 900 millimeter, and cross section of this purlin is 150 millimeter by 50 millimeters. Now third layer is the 38 millimeter by 50 millimeter softwood battens, and it has a center distance 450 millimeters. The last layer is 30 millimeters gypsum plasterboard ceiling. So the whole ceiling has a 1, 2, 3, 4 layers. So we will work out each layers one by one. Let's start with the first one, which is a CGI roof seatings. Now for first, let's start with the flat conditions. We need to have a question of flat conditions, so start with flat conditions, and our first layer is 0.5 millimeter CGI roof seating, which is 0.5 millimeters roof seating. Now I can show you what is the full form of CGI. CGI is corrugated iron and is used for roof. And if I take the picture of this corrugated roof seating, so that is CGI roof seatings. That's what typically look like CGI roof seating. Now for this case, we need to find weight in kilopascal, which is kilonewton per meter square. That is given in the questions, kilopascals. So that's relatively easy. So if I like to find the weight in kilopascals, weight of CGI roof seatings, I can check table A2 of AS 1170.1. That is here on page number 21 on AS NZS 1170.1. It has given steel galvanized standard corrugated seating, and we are looking for 0.5 millimeters. And it has a pressure given 0.05 kilonewton per meter square. So and that is a corrugated sheet. So that's taken here 0.05 kilonewton per meter square from table A2 of page 21. Now this is we complete the first layer, 0.5 CGI roof seatings. Now we can work out the second layer of the examples, where the second layer is a hardwood purlin. So I can show it. Where is the second layer? So we are talking about this hardwood purlin. This is second layers. So for the second layers, we need to find the density of the hardwood, and in the Australian standard it has given the density of grey ironbark. Grey ironbark is the Australian hardwood. So if I show you on the Australian standard table number A1 on page number 19, we have a grey ironbark hardwood. It has a 11 kilonewton per meter cube. So that's given in the density, but we need in the pressure, so I need to work it out a little bit here. So grey ironbark density 11 kilonewton per meter cube, table A1 of page number 19. Now first we have an equation to calculate the uniformly distributed load, that is density times perpendicular area. We have taken some videos how we work it out, density times perpendicular area. So density 11 kilonewton per meter cube for hardwood, times the area, which is the cross section area. In the questions, the cross section area for this purlin is given 150 millimeters by 50 millimeters converted into meters. So 0.15 times 0.05 multiplication gives 0.08225. Now we need the answer in pressure, which is kilopascals, which is kilonewton per meter cube. So we UDL divide by center distance, which is 0.0825, and 0.9, that is given in the question. Center distance is 900 millimeters, so we divide it by 0.9 meters. So that's pressure is 0.092. Now I like to show these purlins. What is where the purlin is located? So if I have a typical roof structures, the location of the purlins is this one, the horizontal members, as you can see there. So these are the purlins in the structure. So this is the ridge of the roof, and parallel to this ridge we have a we have a purlins, and if you wants to know rafters, they are perpendicular to this top ridge. So that's how we identify purlin and rafter. Now we've completed the second layers. Now the third layers, yes, we have it in our questions, is third layer is battens, softwood battens, which is 38 millimeters by 50 millimeters, and center to center distance is 480 millimeters. Now if I like to show the battens on the roof structures, so the battens, this is a ridge and the battens are located here, and then they are purlins, and these are rafters. So these are battens. Now let's work it out, the third concept, the third one, battens, loading of the battens, and it is softwood. Again, we're going to go in the Australian standard to find the density of the softwood. Now in Australian standard, the softwood we can identify from table A1 on page number 19. We have a dog class fir, which is the softwood, and it has a value of 5.5 kilonewton per meter cube. So that's 5.5 kilonewton per meter cube. Now we first calculate the UDL, density times perpendicular area. So density is 5.5 kilonewton per meter cube. Area is given here, which is 38 millimeter by 50 millimeters. So we can convert into meter, which is 0.038 and 0.05. So we get the UDL load 0.01 kilonewton per meters. Now once you get the UDL, we can calculate the pressure equal to UDL over center distance, which is the pressure, which is UDL 0.01 over the center distance is 450 millimeters. So that center distance is 0.45 meters, and the final pressures would be 0.023 for the third battens. Now the last one is the 30 millimeter gypsum plasterboard ceiling. I can show it here. The last layer here, that is 30 millimeter gypsum plasterboard ceiling. Now for this case, we need to calculate the pressure for the gypsum plasters. If we check Australian standard table A2 on the page number 20, we can find that gypsum plasterboard, table number A2 on page number 20, we can find it on the ceiling sections. We can find the gypsum plasterboard, which is 13 millimeters. It has a 0.13 kilonewton per meter square. So we have 0.13 kilonewton per meter square, which is table A2 on page number 20. It's in the ceiling sections. Now total dead load due to these 4 layers, we first calculate 0.05, which we calculate for the first layers, 0.05 kilonewton per meter square, that is here. Second layers is a hardwood purlin. So hardwood purlin we calculate 0.092, which is 0.092. Third layers we calculated 0.023, which is the softwood, which is 0.023, and fourth layer is gypsum plasterboard ceiling that we found from the Australian standard 0.13. We add them all, which gives us 0.295 kilonewton per meter square. So this is the first case where we have a flat ceilings. Now second case is a 10-degree pitch. The question is asking to find the 10-degree pitch. So if I show the roof pitch here, typical case, so this is the flat conditions and this is the roof pitch, 10-degree given for this one. Now we need to calculate the dead load at 10-degree pitch. So we need to looking for dead load in these positions. So it's quite simple. If you take the cost relations, cos 10-degree equal to this flat conditions, which is this line, divided by this hypotenuse, which is dead load at 10-degree pitch. So to calculate the 10-degree at pitch, we switch these two parameters, so which give us 0.295 over cos 10, and the final answers is as a 0.299 kilonewton per meter cube. Thank you very much.